of the Microsoft Fabric uh, training series in Niger Data Platform. So we'll be concluding the series today. But however, we have a physical boot camp coming up 15th, 16th, 17th of August in the maybe next coming months after July. And so we'll also be looking at Microsoft Fabric and some other topics that we'll be looking at, and so you can leverage on that and you can join us. The banner and flyers will soon be ready, so that we all can have abreast information about the bootcamp. But for today, we have our very own Mr. Bayonle Oyetoro, who will be taking us through today's session. He's a data engineer expert with vast knowledge in machine learning and AI governance. So we welcome you warmly, Mr. Bayo. Good afternoon, sir. Please confirm if
Yeah.
you can hear me.
Yes, I can hear you, ma. Good afternoon. Good
Good
afternoon, everyone.
afternoon. Okay, so you have the floor, sir.
All right. Thank you very much.
You're
Thank you,
welcome, sir.
everyone. All right. So, as usual, I will start sharing my screen now. Um, you can just confirm once you can see my screen. Um, all right. So, from my end, it's telling me that I've started sharing my screen. Please, can you confirm if you can see from your end as well?
I can see my screen. Can one or two persons confirm if they can see from their end?
Yeah, I
Mr.
can see
Olushek.
clearly.
Okay.
Okay.
All right. Okay. So,
Yeah.
let's always do a recap of where we are. So everybody that joined today, and then people that might have forgotten a little bit of what we've been trying to do, so that they can catch up. Everybody can be on the same page. So the thing is that we're trying to create a model on Fabric. So the model is just going to predict if a loan is worthwhile for us to give or not. So somebody can walk into maybe wherever we are using the model, give us their data, their background, and then some other things. So the model is just going to respond, oh, this person is qualified for the loan and not qualified for the loan. So, and the data set that we are using for that has all these previous loans that has been collected, and then what we're trying to use to map those input to output is that the status of the loan, whether it was repaid back or not repaid back, were actually provided. So we are trying to read the criteria of people that repay the loan, and then people that didn't repay the loan. So we are trying to map their profile to consolidate on that, and then so that our model will be able to give those kind of predictions correctly. And then while we understand that we can do that locally, we want to really use Fabric to do that. And then the major driver for that is that Fabric is end to end. So when you're building it locally, you need to be connected to a lot of things, a lot of sources at the same time, using a lot of tools together. But all those tools have been provided right here at Fabric. So everything is together. As a data scientist, you can leverage and use what engineers have built or what other persons has built as well. So even the analysts can or developers, they can quickly use or interact with your model that you built very easily from that end. And then to really um, show how Fabric has been, what Fabric is all about. So we come to Fabric environment. We created a workspace that is having the trial version on it. So if you don't have trial, you can try to get one or you pay for the license. So once you do that, your workspace will have those premium access. Then we started, so if you see right here, I'm coming a little bit. So here I have my DP600 workspace created. So what I did here is that I just designed a workflow up. We designed a workflow up here, which tracks all the process that we are trying to do. So we are trying to store the data, explore it, train the model, evaluate and score. Then we apply the best model. And then if we want to use insights from those data, we can also use data. So what happens here is that after we've cleaned our data and everything, we'll store it back to um, the a storage location. Then we can also visualize from there. This is majorly done by analysts, though. So now inside our fabric, if we want to see what is inside those objects that we have in our fabric, we started by creating a lakehouse. So lakehouse is just a storage where that can scale, that we can use to store our data in different formats. So majorly, this lake house or other sort of data warehouse are always provided by engineer. So that's kind of thing that I focus on day to day at work, building pipelines, create something like this, both on Fabric and locally and other platform as well. So after you create your lakehouse, the first thing you need to do is bringing in the data. So what we did that time was that this is our lakehouse environment now. So I'm opening a lakehouse now. Let's try to ignore this. So let me delete itself so that we can. Please, is my screen static or is changing? I want to be sure that it's not static.
It's changing.
All right. Okay. Thank you very much. So in the Fabric environment, we already created in the lakehouse environment, we've created a lone lake house. That's the LHS there. So we imported the data set from our local machine here. So you just come to upload your upload files, then you follow the prompt, and then the CSV will be right here. So after creating the lake house, you already bring in your data. That is cool. But uploading a CSV file is not even always the route you always take. So as I said earlier, all those things are always provided by the engineers. And then if you don't want to do that, there are a lot of ways that you can bring in data here, from a link, just like the way we do in Excel. All those different kind of connections can be used here as well. So, and then important part here is that we can even use API links, all those kind of links here to get the data right there, even from Azure directly. So after we created a lakehouse, we moved to creating a notebook, because what most machine learning scientists or data scientists are using to build now is notebook, because it allows us to write our code and check the outputs on the spot before we proceed. So, and that is also provided in the lakehouse. Sorry, in the Fabric environment. So one thing there is that all those objects that we are creating house. This is the analytic endpoint and then the semantic model of the lakehouse. So this is the notebook that we created. You want to create another thing, you can just come to new. You can create a lot of things right from this lakehouse. So that is one advantage of Fabric. Everything is together. And then we also mentioned that in Fabric, there's opportunity for us to create environment, not just we running our code. Because you see this kind of code that is here in this first line, we're trying to import Imblend. Imblend is something that allows us to apply smooth sometimes. So what happens here is that if we disconnect this, close this down and come back, we have to rerun this thing again. We keep install over and over again, as we don't have a running session, a connected session at that time. So we have to be doing that over time. If you don't want to do that, what we can do is just go to where we create environment in the workspace. So environment can be created just by going to your workspace again. So it's kind of loading. So let it come up. So here, let's try to um, bring this one down. Here, we want to just say, what can we create from our environment? So let's go, oh, I'm in Power BI option. So let me go to data science. I come back to, um, yes. So I'm in data science, always kind of like check. It's because I was trying something out in Power BI earlier. So here in our environment, we just come to the workspace, create new. So what do we want to create? We can just come here and create an environment. So in the environment, we can install those libraries that we often to use most of the time. Even though most of these library are some of the common ones that you will need are integrated in the environment already. So, but you want to use like let's say OpenAI API, where you need to install the library or Azure or any other stuff, you can easily use them in, create it in your environment and use them. So to see that, if we click on the environment, it's asking us for the name of the new environment. Then let's just say env um, loan. So let's call it env loan. Um, so the moment we create that, it's going to take us to a new tab. We're going to open up a new tab for the environment. So we can see here that we can bring in a lot of libraries that we want to. So let's add one library. So here, if we come here and say we want OpenAI, just type OpenAI, and then you can see OpenAI is here, and you can easily select the version of um, libraries that you want. So that is how that's one another extra advantage in of Fabric. So to do this locally, we would have gone through the route of creating a virtual environment. We have to use some space in our computer to create those environments, Python minus M, .venv. So we create those things, then we now start to keep installed. Here, the experience is quite different and easy. So after that, let's say for our workflow, we didn't create any environment, we just come here. Now, the first process is data ingestion. So what we did here, let me try to like put everything together so that it can, yeah. So the first thing we are trying to do is data ingestion from the lakehouse. So this is just we setting up the room to kind of like not get a lot of warnings when we are trying to run our code that has warnings. So to do that, the first thing you always notice this, you already have a notebook here, and then your notebook must be connected to the lakehouse. It's very important. If you don't do that, you will keep getting error. So to do that is that just go to data sources here, and then you can just go to lakehouse. It's going to bring all the lakehouse that you have. Then you can say add, or you can even create a new lakehouse on the fly or anything. So it must be attached to a lakehouse. Your notebook must be attached to a lakehouse. The second thing is that it must have a connected session. You see, this one is not connected at the moment. So if you try to like see this right here, if you run all or do any kind of run, it's going to try to build a session for you. And you can create it without even running anything. So let's just come to connect. And then I want to start a new session. People that are used to Spark, we understand all these kind of sessions. So uh, within a session, you see it's running, then a standard session has been created. And autosave is on. You can go ahead and disable it if you want, but I think autosave is a cool feature. So now we have our notebook here. We built a session. Now we can start working. What we did was that we ingested the data through with this code. So we kind of connect to our lakehouse with this Spark code. Then we transform the data to pandas that most everyone is very familiar with. Then we print the head of our data to see how our data looks like. So let me try to run all while we are running through the code so that um, our work we continue. So after bringing our data to the environment, changing its pandas, that means in our notebook, we already have a data frame. So the next thing we do was that we said initially, traditionally, we try to like explore data with visualization tools or libraries like Matplotlib and then Seaborn. So we try to just customize the themes, and then also we import pandas on NumPy. Yeah, you know all the libraries that you need. So it's okay to even be importing your library as you are going on, as you're moving on. There's no problem with that. So we just try to showcase this so that we see how we import and all. So if you want to install something, pip install, we can do if you are using Python or it's different for another language. So for Python, we're just going to use %sign as we see it right here. Okay. So we are going to pip install as the one that we have right here. Okay, so here. Moving on now, we try to display our data frame. So we display and we want to just see the summary. That's why we have summary parameter is equal to true. Then we can easily see all our features. Features are what we have in our data set, the columns, to see what we have, like what we are working with. And this can be longer. Then we also preview again to be sure that we still have that DF. Now we want to begin our data exploration. Here we just want to check how many rows, how many shapes. That's what we're trying to do here. So we try to say initial shape is we have 32,000 rows, 12 columns. Then we remove duplicate with this line of code. Then our data was reduced to 32,029. Then we try to group it together just in case we might need it or we want to use it. We group it into numerical columns and then categorical columns. So we just print the name of the column. We said for all the in the data frame dot columns. So data frame dot column will return all the columns. So we now say that where the column type is equal to object, grab the name and put it to numericals. It's not object, but if it is object, grab it and put it in categorical. Numerical is data that has numbers. Categorical is just data with maybe yes, no, house, rent, education status, all those ones. Now we move on to now say locally, we also demonstrate an advantage of Fabric here, where we said that we could have written a lot of Matplotlib or Seaborn code to visualize the data, but we use the advantage of Data Wrangler. So by the time you try to like do this, so the moment you are running your code and you are saving some, like let's say data frame and everything, they are actually coming here. So what we can do here is that you click on the data set that you want. So let's click on data frame, which is where we started. So um, you can see the data wrangler is coming up. We could have been writing a lot of code to do all those things, all these kind of operation like cleaning, exploration tasks, but we can easily see it here from our what's it called, data wrangler. So we can see the distribution up here. We can even visualize our data. We can see some missing value, distinct value, and then that's not all. The best advantage of Wrangler is that we can come here and do any operation we want to do, from removing duplicates, replacing duplicates or missing values. If you want to do encoding, if you want to transform the data or round up or round down, change the sort and filter, everything can be done. So if you now do any operation here, after you finish doing the operation, the code are automatically generated. You just click on add to notebook. Then you'll be back to your notebook with the code of those operations that you've done. So this is an example of code that was generated by Wrangler. So this one saves us a lot of time to explore, to visualize. So it saved us a lot of time. Most of the time, the data set is too big. You might still need to go through the route of trying to do advanced exploration. So we generated the code and then we ran it. Here we preview what we ran. We gave it DF clean. So we saw that the data set has been cleaned up and then distribution has been normalized to an extent. that is okay for us to continue. Then we try to display the summary again. Here we can see that all the missing columns, everything has gone away. And then we have this there. So here is almost a very good practice here that by the time we clean our data set, that sees all the columns are clean, we try to write that data back into our lakehouse. So this is the code to write it back. So we are just trying to tell the notebook that, okay, once this one is run, go back and create something in our lakehouse. So initially when we start, there was nothing in our, we just go through the route of files to bring our data here. So if I click on files, you see our data set that we imported is there. But once this code is run, this data frame is generated. So let's try to even do and then see if it will generate again. So let's create D2 and then try to run this cell again. Okay, I want to see if it's not going to alter it. So yeah, no problem, it's not going to alter it. So let's try to run it. We can see the job is running. Now, it's trying to create something. So let's wait for a sec. It should come here. Data frame clean 2 should actually come here after it finished running. So it has finished running. So let's refresh. Yeah, so we have it here. And then why are we doing this? The reason we are doing this is that instead of us to go back and be running our notebook over and over as we normally do locally, if we have any issue, we can easily save it in data frame. All these one are now tables, everything is here. And the amazing part of it is that this table that we save it as, that is here in our lakehouse, can be consumed by anybody. Let's say our analysts want to work on clean data. They can easily come here now and work on this data. You can use it to build reports. They can use it to do all these kind of things. Now, once all this one is done, we see that we want to begin with, we want to continue with data preprocessing. Preprocessing is that we are trying to, you see all these ones that are in number, letters, categorical column precisely. We want to encode them. We want to normalize our data set or standardize it, or we can even want to do something like encoding. Yeah. So all of those operations are part of preprocessing. We might even want to do feature engineering. Let's say we are supposed to multiply two columns together to get a new column that can be helpful to us. We do all those things in preprocessing. So that's what preprocessing is all about. Yeah. So instead of us to now continue with data frame clean and everything, you see what we did? We just write from our table. We just write and say, we have this operation done here, and our data, clean data has been saved in tables. Just go and pick our clean table, and that's what we want to use to start. If you are coming next time around, and then you just want to start afresh, you don't need to start all those process over and over again. Just call your clean data set from the lakehouse, and you begin your work. So anybody that wants to do this work now, they don't need to go through the route of get the source data and everything. Just come to the clean one and begin the work. So you just do pre-processing and training. Very um, easy environment. So all these one are quite easy because we are using Fabric though. So here now we have our data sets that we are going to work with now. So we want to begin with encoding. So what we're trying to do here is that we are trying to explore different options we can use to encode. So the first thing that we do here is we are trying to, you see this particular column, where is it? This long grid column, F, E, G, G, others. They are in letters like A, B, C, all the way to G. So we want to replace it with 1, 2, 3, 4, 5, 6, 7. So we use this code to write it. So we create a new column called encoded grade. Then it's coming here to check if is it F is going to give you 6, is it G is going to give you 7, is it A is going to give you 1. So all of those ones are what we created here. Then we remove this one and rename the new one to long grade again. So that's one way of encoding. Another way of encoding is this. Let's say we can use lambda. That's a Pythonic way of doing it. So we have a column that has yes and no. So we want to change yes to 1 and then n to 0. So we can write it like this on one line. Python is capable of doing that. So we just write it as one line using lambda, and then the column is transformed to 0 and 1 respectively. But we need to be careful when we are doing encoding, as we said in our last class. Ordinal data, numerical data, categorical data, all of them has some sort of implication on the way we encode them. So we need to be careful. Now, another way, which I prefer, the easiest way, is using the Wrangler as well. So we use the Wrangler to do encoding, and then the code were generated here. So that's kind of like very easy and then very straight. We could have worked our way through all the encoding with Wrangler without writing any line of code, just by pressing and selecting. So by now, let's see what we have. So we have our encoded data set. So if we look through it now, we see our data set has been encoded properly. We don't see um, categorical data as we started. Now we preview what we have again. So there's no missing values, and we try to confirm our data type, everything is okay. So what we now do next is that we now split our data set. So here, to split our data set, we don't need to, we can manually do it, but we have libraries that can do that, sklearn. So we said from the module selection, grab this string test operation. So it's basically, I think, a function, or is it a method they call it. It's just very different in different languages. So this function here, um, we just say, you know what, split our data into encoded.drop, that is, grab all the data set except the known status. So everything will be grabbed in our data set, everything all the way to this place. So our loan status is just going to be the one that will be missing in our X. So we now separate our loan status again. So we have two data sets now. Two variable now. One is for all our data sets without the loan status that we are trying to check, and everything, the loan status that we're trying to check. So we have target and then every other thing. So now, when we want to now use the method that we call, this is string test split. So it takes in two parameters basically. So it takes into the two parameter, that is our x and our y that we splitted. So this method is going to do a lot of operation. You can check the documentation on sklearn if you are interested. It's going to return four variables, which are x train, x test, y train, y test. So here we're trying to say, what's the sample size of our test data? So this one is going to split it into 80-20. So as we have 32,000 rows, 80% of this is going to go into training, and then 20% is going to go into test. There is no specific generalized stuff that you should do 80-20. You can do 70-30, 60-40, just that you need to understand that people have worked on building several models. So they've tried several approaches to be able to come. So 0.2, 0.3 are the most common, which is quite interesting, because you don't want to train your data with less data and predict more. And you don't also want to just predict very small stuff, so that you will be drawing some sort of not comprehensive conclusion. So this random state does that anytime we are trying to pick if we didn't include this random state, anytime we are trying to run this code over and over again, is going to be grabbing different part of the data. So our split and train test is going to be different data every time we run our code. So that is why it's always very okay to put in this random state. So random state is to ensure that the randomness is going to come in this space. So again, this 42 is just, you can easily put it somewhere, but 72 and then one other one is very common as well, with some statistical backings. So if you use 42, it means that if you do this experiment again, you can reproduce that same experiment. So if you don't use it, your experiment is not going to be easily reproducible like that, or it might not actually be at the end of the day. So if you do this, that means you fix your randomness, the data set that is going to be grabbed, you already know that you can reproduce that experiment. If I change it to 50, I can reproduce experiment that will happen on 50. So that's what we're trying to do here. Here, we're going to do standard scalar. So we are trying to scale our data set, trying to control um, these parameters like standard deviation and all that we have on our data set. So we already explained all this one too in our last class. So what we did here is that you see, I could have renamed this one to be let's say what can I do? So I could have retrained this one to say X train scaled. Some people will write X train scaled. So that means they have a new, but here as I'm using X train, I'm trying to replace this X train. So as I'm declaring a new variable, this one will be updated. So now here I use X test as well to just match it together that they are in the right order. So what we do next is that sometimes you might not do standardization. You might want to do normalization if you are trying to work with some models that are like range sensitive. They are very sensitive in the range, so you might want to normalize. So one of those experiments, I think, is it KNN? Yeah, maybe KNN, and then some neural network as well used to focus on that. Here, now, this is an advantage of another advantage of Fabric. So we've splitted our data, we've tried to standardize it. And then if you want to even know more about all these concepts that we've been discussing, if you go to our GitHub repo, you can see those links that will help you to easily pick it on the spot, even if you are not from a mathematical background. Here, what we are trying to do here, I think this is where our main work starts today. So is there any question from anyone so far about what we've discussed here before we kind of dive into what we have today? Just itself. Okay. All right. There's no question in the chat box as well. So, but if you have question later on, you can put it in the chat box. Then I will try to be checking at intervals to pick something. Okay. What we're trying to do here is ML flow is just a way to really manage our pipeline from ingestion down to deployment. So here, ML4 is just that we're trying to, we use it in such a way that we try to track our experiments here. So this code has been run, so there's no need to even rerun it again. So what we did here is that we import MLflow, we import MLflow. This this one is open source, generally available. It's a common way people log their work. So most of the ML that we ML or AI procedures that we govern and review these days, they are already working more on the ML flow. So we created a variable called experiment name, and then we name it lone default experiment 3. So, and then the reason why we are calling it, yeah, the reason why we are calling it experiments is that data science is not like software engineering where you write your code, you see output, and you move on. So here is just that we are trying to try several approaches to solve something. So that's why the name experiment is coming in, and we will see experiments in Fabric and see how it looks like as well. So MLflow has been integrated. The open source MLflow has been integrated into Fabric as well. So you don't need to be calling the library or the API anytime. So now we set autologging. You see, this autologging can be set to false sometimes. So the default one is true. So the reason why it's true is that anytime you are trying to run something and you even forget to do auto logging, you forget to log your experiment. Fabric is going to by default going to do it for you, log it in and save it in experiment for you. But here we try to override it so that we can configure what we want to even bring into the environment. We can configure what we want to bring in the environment. So here, I'm just showing you that you can turn off your auto login or And then the only way for now by Microsoft to interact with this ML flow, to really configure this ML, I think is through code. So it's through code that you can control those things now. Maybe a GUI will be created later on. Yeah, so we already create our experiment. So we said msflow.set experiment, we call the method, then we pass in the name of our, so we could have just even typed quote unquote loan experiment, very easy, but it's always very good to have it as a variable like this, kind of aesthetically okay. Here now we import the required library for model training. So here we already talked about some models that we can use for classification problems that we're trying to do. So basically in machine learning and then AI field today, most of the common problems that we see, we've seen people trying to solve so far is classification problem, regression problem, and then clustering problems. They are very, very common, even though there's still exploration to see what AI can do better, what other things that we can apply it to. But for now, there are different kind of classification problems, multi-class prediction, or binary classification like we're trying to do. So 0 and 1, yes or no, buy or not buy, those one are binary classifications. And there are some models that are very okay for it. So which is why we said that to even be a good scientist, you must be able to go and study. And that's why we provided those links that you see on GitHub, so that you can go and check that, okay, you know what is random forest doing? What is logistic regression doing? Even though I don't write ML script from scratch, I think I just did it once just to bring me to up to speed. But now that we basically focus on governance, we need to just know how those things work, so that once they see it, we can be able to check it properly and then provide proper guidance. So we kind of like always understand what is going on behind the hood of what random forest is doing, logistic regression is doing. So you can even still go see this on YouTube very easily. But the link that we provided is kind of very low level and very easy for majority of the people that are not from data science background. So we import all the models that we need, specifically light GBM, random forest, logistic regression, SGB boost, and then SVC supporting support vector machine. So here, we also import some metrics: accuracy score, A1 score, precision, confusion metrics, recall, area under curve, classification report. So all of these ones are what we've also discussed in our last class. But just to go through over it again is, I think when we print our confusion metrics, we can still go over it again. So now, we now want to, you see, initially I turn off my auto login, but now I don't want to go through the stress of even logging a lot of things myself. So I enable to log in here by writing the name of what I want to do. So I write the name and say the register model name is logistic regression. So I want to train my model on logistic regression right now. And then what we can do here to train your model on logistic regression, you see, we already installed, we already import linear model, logistic regression model here. So what we are trying to do here is that we try to bring it in again for reproducibility. We try to create a variable, then call the method of logistic regression random state. So what we do here is now that instead of us just, we could have just written this line of code and run our model and go on. But we want to log in, log all what we are trying to do here. That is why we start with this particular line here. So here is to capture the run ID for this model prediction for later. So this is the parameter, this is the code. So we said start the run, and then the run name is what we declare up here, and then we run it. So this code that we have here, so we said print the run ID and the status. Then this is just format of what we're trying to do. So we could just pass in all this one inside, but so if you come here and write something like, let's say F, and then that means we can pass in the name of all these guys inside, but that's not what we did. We just call format method. So We have our run ID, we have our run status. So that is for that particular operation that we want to do now. It's going to create an experiment called logistic regression, and it's going to capture the logs that we want to do. So what we now do after that is that we now begin to train our model. So we train the model on logistic regression. So training model is just we're trying to draw lines. We try to go through the mathematical concepts behind it. So it's even what we don't want to focus on in this class, but it's very easy as well. Just go to YouTube, one of those links. We begin to evaluate the model. So we do build test score, the prediction. We split our data set into Y tests, X tests, X train, Y train. So what we now do here is that we now begin to visualize our metrics. So most of the models that we use in classification tags, we kind of like use confusion metrics to build accuracy, precision, recall, to predict what, to even examine our model is doing. So most of the time, that's what we do. How many do you get right? How many do you get wrong? How many out of the one that you get right? The one that you're supposed to be even be yes, how many of them do you get? The one that are supposed to be no, how many of them do you get? So those are the kind of metrics that we are trying to do that they call accuracy, precision, recall. So here now, we now come here and say log this metric manually. You see, we disabled it earlier. So now we now say log the metric accuracy AUC as well. So this is going to create an experiment. So let's first see the output before we go to the experiment. So the output is this. Our model has been built. Then we now have zero. Zero is like people that didn't pay back the loan. Y1 is people that pay back the loan. So we have a precision of 80, 83. So we can evaluate our model easily from here, like on the spot like this. Now, we can now even come here and say that, okay, we created an experiment. Even if we don't create the experiment login, if we don't create the experiment login, you can see the run ID, all those ones that we printed earlier. So, and we can easily see accuracy right here, 81. And then we've explored this one sometime last week that we don't always take accuracy as our only metrics. We combine a lot of stuff based on what we want. You can now see here confusion matrix. This is the confusion matrix that we can still print out in a fancy way, but this is just what we are trying to like point out. Now let's see if you don't do what's it called. If you don't do your experiment, if you don't specify or interact with it via code, Fabric will still create this one automatically. Why? Because most of the people forget to do that, and then there's nothing bad in getting your logs for you. So the name will just be something very funny. It can just be "Don't go there" or something like that. Here now we've created it, logistic regression experiment that we created, and it is finished. So should we go there immediately? Let's see how it works. So if you go to experiment, let's quickly go back to our DP600 workspace. You see, when we started, we only have loan, which is loan LH, which is our lakehouse and notebook. But with that thing that we've done now, you see this environment that we created to just showcase how we can save in some libraries. But this is the experiment that we created on the fly during that model training. So if you come here now, we can easily see that, in fact, all of the model that we created now has logs. All of them has logs. These are something that you will be racking your head to be doing locally. So you see everything is if you can even easily add somebody to your workspace and they can monitor these things that you are trying to do. But for them to even see it locally, you have to be rerunning your code or showcase your laptop and everything. Everybody can easily come and preview what you're trying to do. Now let's see what is saved in one of those experiments. Here you can see we did auto login here. You can even specify what you want to bring in. There's nothing bad in that. So let's try to check our confusion metrics here. we can see it's 0.84, 0.16, 0.22, 0.78. So we can use this one to now evaluate what we are trying to do. So instead of creating confusion metrics from scratch and all those ones, we can easily do that. And funny thing is this, um, anytime we're trying to consume a model, we always go through the route of saving it as a PKL file, a P2 file, or we can save it as what's the name of the other file? That maybe job.lib. So now here we don't even need to be stressing ourselves to try to like write the file out explicitly. The experiment is going to have the model inside, and we can even version this. Let's say this is our first run. We can save them in a folder and say first run. We can come again and create version 2 and say this is our second run when we try to like maybe clean our data again or change some things in our experiment. We can have different versions. So, and then data science is not all about you go with this is okay. You kind of like target what you want and you statistically review it, which one you want to go for. So now we have models, we have all our parameters saved here, and then let's quickly head back to our notebook and see what happens with the rest of the code. The same thing that we've done up here, we just do it here. So what you can do is that it's quite uncomfortable to even know how MLflow codes look like, but it's still not, it's one of the stack that is expected from the data scientist to like be able to do. So something like Spark and then MLflow, and then what else again? I think those one are the major ones that you need to focus on. If you want to even be very good with MFA, be good with logging, or just go beyond traditional ways of training model. So you can just head to MLflow website. You can start learning it one after the other. You won't get it in a day, but with time, as you are using it to practice, you get comfortable with it. It's because the class is not focusing on explicit coding. We could have started to like, by the time before we call any method, we'll be trying to explain what's going on and everything. So we'll be doing more of coding than even getting the concept that they're trying to do. So here, they are just basically Python. So now we have all our login for all the models that we have. So we can see some good values here, which is which model is this? SGB boost. Yeah. So we can even see which one is this. This one is random forest, and then this one is this one random forest. Yeah, this one is SVM, and then this is random forest. So what we now did at the end of the day was that we try to print our own cost that okay, what time does it take for our model to even finish all what it's trying to do and everything. This is just 97 seconds because our data set is tremendously small. But if it's a huge data set, when we are trying to train maybe commercial ML, that's enough. This thing, you will see significant increase in the number. And then it's not something that we can do like this in a day. We have to think about the project, how the data sets we want to collect. It can take up to like almost 6 months to even finish all those things. And sometimes your compute might not even be able to carry it locally. So if you come here, you can easily leverage on those kind of complicated framework that is here. So now that we have this, let's head to back to our experiment and then see something. So let's say we want to even report what we are trying to do. How do we do that? We don't need to be going and be checking those confusion metrics most of all the times and everything. We can just come here. Yeah, so we can just come here now. Yeah, so we come here. Let me go back to where we went to so that it won't look like we are trying to jump. So let me go back to DP 600. Yeah. So what I did was I head back to my experiment created via the code. Now I come to the runtime. Sorry, I just click on that particular view. So now I want to check the performance. as I drag this guy up, so let's say I want to check the performance of random forest and SVM. Those are the ones that I will select. So let's even just check only random forest, SVM, and all. So we have this now. Our model is built. We can see accuracy, we can see log loss and all those things. So I will go back to explain cost functions or loss functions that we are trying to, if we are trying to do some sort of regression problem. So now let's say here, we just select the three models that we built. Now I want to check the accuracy. We can easily see the performance here. So we can click on this edit button. Instead of line, we want to see it as a column. Now let's try to replace it. You can easily see the accuracy score for each of them now. That you see this one, you see this, you see this. You can do the same thing for every other thing that is there. Let's say you're trying to visualize time as time goes on and everything. You know, what's it called with the group? That line chart will be okay. So now we can come here and then column again. So we can see a lot of things here. Training accuracy score, one score, and log loss. So we can use that to now say, okay, which one is even a very good fit for us. So with this one that we're having, I think we even, I would advise we go for, what's it called? Which of this guy? The XGB boost, because when we print the confusion matrix earlier, we saw that the number is kind of like great for precision recall and accuracy at the same time. And then the reason why that is because the way XG boost algorithm works. So it's the way it works. And SVM is not even trying to build a model like that per se. It's just using some supporting vectors to do that. So by the time you check how those algorithms work, you will even be able to say that, okay, don't let me go through decision tree. Let me go and use random forest, because initially, let's say someone that is not very comfortable or understand how these guys work, the person will try to use random forest and decision tree at the same time. But decision tree is kind of like less in performance compared to random forest. So all those kind of things will really help. That's why we always encourage to like make the effort to check this kind of stuff. So in the governance part, this is what we basically do. We try to like just check your code, then we come to performance, and then we review and try to like make some sort of decision based on what you are trying to build. So sometimes you can trade accuracy for precision, some other stuff like that. And then it's because you're trying to do the classification problem. And this means other thing is another metric that we'll be seeing right here. But the concept you are trying to grab is that how to use Fabric to your advantage. So the data science part is another thing. Fabric is another thing. So as a data scientist, these are some kind of tools that can, and you see a lot of metrics right here. So metrics that you don't even use your hand to compute. You can see a lot of them right here, and you can even see some parameters right here, all of it. These are something that you won't see in a traditional computing environment. You need to be calling them on and on and on and on like that. So we already see it like that. So let's go back to our lake house. Oh, sorry, our now this is just the workflow of everything that we are trying to do. So now let's now say our model is 40 and we're trying to build in something. So we can go back here to our notebook, edit what we want to edit there. Let's say, for instance, yeah, let's say I want to change the depth, max depth of this random forest. So it's just like in random forest, they kind of like create some layers of forest with node. So those kind of stuff that we're trying to do, we can even increase it. We can create a layer of trees. And then here we can say how many features should you use, 4, 6, anyone that you want. So based on those things are something that you have to go and read about. So if you read about, let's say the max depth, what is meant by the max depth, you will be able to tune it very efficiently. So that's one of the, you see the way we mentioned random state and all those that we explained. So that's how you will even understand how every other ones work. So let's say let's see one of the other models and see what's different. You see in SVM, the parameter is a little bit different. It's probability and the random states. And I'm very sure for logistic regression too is also going to be different. So this is XGB Boost. So all of the models that you are going to use, there is no rule of thumb that every model has this parameter that you can tune. That's why hyperparameter tuning lecture is always very different from every other lecture. So it's going to be model specific, model algorithm specific. So, but all those things can easily be edited and work with or reviewed inside Fabric. So with this now, we've already built a model. Let's now say we want to go for one of these models. After the governance guy review and everybody review, everybody's on the same page, accepted. There's a lot of back and forth, obviously there will be, and it can take a lot of time. Some models might not even make it to production. So let's say we have done all those things and we want to pick one of the models. So what do? We kind of like come to our workspace. Yeah, let's come here. So we can save this to our PC here. I'm coming. Let's try to come here. Let's say we want to go for, let's just pick this one because we didn't properly review what's going on there. So let's pick this one. You see the file is not supported here. And I know that with time, it will be easily supported to even consume space. So let's come to the logistic collection and save the model. So create ML model. We want to create it in a folder, and then let's say LG logistic regression model. So we have LR saved. So let's say we've saved it as LR now. So let's try to like come to, yeah, so let's do it. So we've saved this particular model now. You see the version has been saved. It's still trying to load the model. So let's see what is being called. Yeah. So we've saved first version of the model. Let's say we can rename this one to anything that we want. So version one of what we've saved. You see the model is just being saved, or only the model, different kind of endpoints. And we even have requirements. That is what you need to install to be able to run the model. So we've saved the model now. How do we do this? Let's come to apply this model. Copy code to apply. So this is how it works. You want to apply the model. If you build a model, usage is just that you're trying to say now somebody can come and predict something, then you want to see the response. Somebody come, put in your data, then you see the response. So now we can apply it through different methods. The simplest one so far is this copy code to here. You can see your code is being here and everything. So let's kind of like copy the code to. Now we can go and open a notebook and apply the code to test our model. Another way that we can do that is that we can even select our, let's say we want to test it graphically. Another one that we can do is let me try to like go to my workbook and try to see if I can bring some data here. I don't know if that's going to be really visible. So I'm coming. Okay. I'm trying to select some data so that okay, this is not even okay. So I want to select some data and put it in my what's it called? New notebook so that I can see if we will be able to test it on the spot. So I'm saving the data as testing. So let's save it as a CSV. Okay. Oh, you won't be able to see that part here. So it's because I'm sharing one screen. So let me close this part and then close this part again and come to my environment. So let's close this one off. I think I need to bring the data to, to that particular place. So let me remove, okay, what data say? Okay, check. I think the data set is saved somewhere. So I want to go and get a data that has all the column except what we are looking for. So let me put it somewhere here. Yep. And try to like save it as something on my PC. I will now bring the data to Fabric or Lake. I'm sorry, Lakehouse. So from there, let's call it testing, and then we call it CSV. CSV. Or CSV. Okay. All right. So let me check my computer is there. So I think it's there now. So this is my lake house. Let me bring in the new data set and see what will happen. Yep. So testing okay. So override if it exists. Yeah. It's bringing into the lake house. So let's see what happens. I think all is done. Loading the contents. Let's check this guy. So let's check the testing. So you can see in the testing, I think the loan status is still there. Yeah. So let me still reconfigure it very fast. Um, okay. So let me remove it and then save it again and try to bring in another one. So let's upload again. Okay, let's bring it again. It's going to override the existing one if it's there. Yep. So successful. Now let's refresh and then we can see a new what's it called, a new CSV file. I don't know why the preview is not even coming out. So let's try to refresh again. Okay. Let's try to delete the other one that was there before. Um, let's delete. Upload. Okay, let's give it testing two. Yep. All right. Now, let's upload again. Hopefully, it will work this time around. Testing two. We upload. Yeah. So it should display all the content this time around. Hopefully. Yeah. So we see that it stopped at loan percent income. The loan status is missing stuff. So let's try to check the other guide that we are doing. If we go, so let's apply this version in a wizard instead of copying the code. Lakehouse input some tables. So now we need to move that guide to table as well. Uh, let's quickly move it to tables. So here we load to table and then as new table and call it testing two and say load. So we are trying to have a table format of it now. Yeah, it's still not there. Let's see. Yeah, so you see it now. So checking back the model. Oh, it's still loading. So let's say successful. Apply this model in the wizard. Then load. Let's say testing. Loading the preview, it could take some sort of minutes. So let's go to next. Mapping column. Yeah, so what this one will do is that input column, undefined tensors. Yeah, so let's say we select this guy now. Now, what we're going to do here is that, you see, we've done a lot of, let's say, operation on our model. So this is why the column won't match. So we've done a lot of encoding, transformation to our model and all those ones. That's why we are having a lot of, let's say, we want to put in something like this. It's still not matching. So we've done a lot of encoding on our data and not like that. And then we have our data in tensors now. So tensor is just like numbers. So the way tensor start from is like we have scalar, we have vectors, we have matrix, and we have tensor. So scalar is just one number. Vector is that we are having the number and some sort of direction. The matrix is that we are even representing it in rows and columns, and a lot of it being transformed. That's where TensorFlow really came up. So what we are trying to say in essence is that if you can transform your data to have those kind of parameters like encoded version, clean version, so once you kind of like select all this column, you can map it. By the time you map it, you can now name your output column that you are going to get loan status. So by the time you now name the notebook and then you run it, you are going to see that data set that we are trying to preview. You are going to see the names of all the columns. That, let's say our data set is missing loan status. The loan status column will be added and then the right prediction will be at the front. So those are the kind of things that you can do with Fabric environment. But the last way to do it, so we've explored three ways to consume our model. The first thing is that we can copy the code that was downloaded. So the second way is that we can do this version, save it, and then come to the version and then apply the versions that we want. So we can have like 7 versions right there, and then we can be applying it one after the other. So what we do is that if a scientist has already built a model and submit it, so we check all the versions that he or she has, maybe like 5 most of the times. So we'll now be applying, we create a new data set, a new input that don't have the predicting column that we are looking for. We'll now start to apply it and map and then run. Then we are going to see our output via the GUI without testing. So we could have written code and do all those kind of stuff. And then the last way, which is a little bit of was we can save it as PKL, and then we can now begin to code with our VS Code. You know, in Fabric, you also have VS Code interaction. So you can come to VS Code and then let's say you can use your VS Code to interact with the model. So let's say I want to run it locally on my PC now. Let's say download the model version. So I'm downloading the model version. It should go to my computer straight so that I will be able to use my maybe VS Code to do it. So let me try to open it. Now let me share my screen so that you can see my entire screen. Let me stop sharing and then share again. Uh, share entire screen. Yeah. So now I think my entire screen is on. So what I did was that in my Fabric environment, I click on this download ML version. So it's going to download it to my local machine. So I don't want to use the cloud environment to run the code because of my computer IT people. So now I downloaded the model here, and then you can see everything that is there: model.pkl and all those ones, python.env underscore env. So what I can now do is that I can easily come to my VS Code. Let me try to move. So let me come to VS Code here. So here I was just testing out. So this is one of the test code to just monitor some gradient descent. Now let's come to our loan here, and then let's close this for a while. So I want to move that file to my, let's say, I think the code is somewhere here. So let's move it to PyProject. and it's inside Loan AI Decider. So let me come here. Now, so you can see the model.pkl here. So this is what I used to build up the GitHub repo. So I created a Loan Decider AI repo. I put my data sets here. Then I have my notebook and I have my README and everything. But now we already built something, a model, which is this PKL. Everything that we want to do is inside this model. Now we are just going to come here and start writing code. So we can write code to build the interface from Streamlit, or we can use Flask framework or anything in Python. So that one is a little bit like you will still now need to know how to do a little bit of software engineering. So all of it has been coded here. So this was what I was doing before the meeting time. I was trying to build a Streamlit for it because on the repo I said, oh, we are going to build a user interface for it so that we can be able to interact direct. So let me go to my virtual environment. This is what I was saying earlier that in your local PC, you have to create the environment and start installing. So this is a virtual environment VNV now. So here I have the code for most of these stuff. Model.pkl, everything is here. Here now also, as you can see, I have my code. What my code is doing is that build an interface that has all these parameters. Then come here, data type, all this is data that I want. Then use it to predict. It's just some sort of, you have to go and learn Streamlit again. So that's the third way. That's why I said it's a little bit challenging. So let's see if it's even going to work. So let's run sample.py if you don't run into error. So I'm yet to change my directory, I guess. So let's run it again and see. Hopefully it will work here. Yeah, so it's working on a port on my computer now. So let's see what we have. So this interface is going to display like a form. So it will be like filling the form. After you fill in the form, you just run. You see this is the form, credit loan prediction. This app predicted that a loan will be default. So we now come here, rent. You see in our data sets, these are the parameters that we saw there. Is it own, is it mortgage? So I select mortgage. Is it personal, is it for education? Fill it. Then we select all of these things. And the data that we put inside is telling us like this. We can even download data as a so I don't think that this will work because I'm here to finish it. So this is an interface for us to even test our model after we finish using it. Our software guy will just take that PKL file and bring it there, and then they will now predict. So once they predict, you see we are having a lot of value error here. It's because this one I haven't had the layer where I handle the what's it called one auth encoding, the transformation that I did. I will add the layer inside my code. So this data set now will be sent to that model. And then all the operation that I've done, encoding all those ones will be done on it. And then it will now return something back. So you will just see by the time we finish, I finish writing the code, you will see under the predict now, it will now say the loan should be given based on this model, based on the second model, based on the third model. So it's going to mention the precision, accuracy that was used by each model up here. So you can see all of those things graphically. And the data that I used to do that will be here. So those are the major ways that we can consume and use our model. And after time, let's say our model, we've collected a lot of data about new applicants of loans, and then behavior of people changes. Let's say the economy now, before people can find it very easy to pay loan, but these days, because of the economy, the way the economy is looking like, a lot of people don't pay loan easily again. So their behavior might have changed. Then we need to go and retrain our model. So there has been a shift. So we'll just come over to our environment again, do another set of training and save it as a new version. So once we save it as a new version, we now start to like, okay, you know what, just take this PKL file again. We've updated this, we've done that. All those ones are done very easily. Before your local machine, you have to look for, okay, where do I write it? Which environment do I use to create the project? But all of this time around, you don't even need to bother about those ones. All of it are together in the same workspace. Then you just come back to where you start as if you didn't leave at all. You just fire on and then move on. So that is how basically we use um, we use Fabric to do data science work at my workplace. So if there's any question for now, um, we can start asking our question.
Thank you very much, Mr. Bayo. Well done. Hello, the floor is open. Please ask your question. You can ask maybe from previous classes, whatever is not clear to you. Any confusion? Is everyone clear? Mr. Bayo, maybe you have to ask your audience question. Let's know who has tried the previous data sets. Where did they stop? Did they have hands-on? Just find out what they have done so far.
All right, okay. I think that shouldn't be a problem. How do we do that? Is it that we call on someone or we just request for a volunteer?
Just as you are led, just ask.
All right. Okay. So I think I have a couple of friends that I've seen their name over and over. Yeah. So
Yeah,
let's
so
start with this. I
just
think the best way is let's start with Mr. Ola. So now, Mr. Ola, have you even joined the class before? Maybe like first time, second time, or you join everything? So if it's not there, we can go to I don't know if it's Mr. or Miss Tosin. No. I think that's common name to both boys and girls. Yeah.
Hello, good afternoon, sir.
Hello, good afternoon, sir. How are you
It's
doing?
Ola, sir. I'm fine, sir.
Yeah,
And
okay.
actually,
So
this is my first time. Actually, this is my
oh,
first
this is
time
your
of
first
joining.
time.
Yes, sir.
Oh, okay, okay. That's not even a problem if it's your first time. Okay. Do you like remember where we said we start if you want to even do the project? Like where we try to start. How do we start if we want to bring in a new if we want to build a new project? Let's say we are trying to build a model that says this is a car, this SUV, all those ones. How do we start all those ones? And somebody else can assist
Sir,
you.
I joined
I
late.
think
That's why I couldn't answer that, sir.
sir.
But I'm actually following whatever you are doing, sir.
Okay, okay, yeah, no problem. So I think Miss Tosin or Mr. Tosin can assist with that. And we want to start building a new project. Where do you think is like the starting ground for us to start? Well, I think some people are not or maybe they're having glitches or they can't hear me. Um, anybody
maybe
that wants to volunteer?
Victor Bassi has been consistent, so maybe
Oh,
I know
let's see.
Victor
We
Bassi
want to
has been
start a new
consistent.
project. Mr. Victor, where do we start?
Tolulokwe, you want to answer? You can please go on. You just unmuted. Please go
No,
ahead.
ma, I don't want to answer yet. I'll answer another question.
Okay, tell us what your experience has been thus far. Just go ahead.
My experience thus far, I like the way of teaching of Mr. Jamu because he's quite, even without asking questions, he offers information very diverse. But I'm not so familiar yet with how to use this properly. but I
Okay.
gained a lot from him, and he was able to show us how expansive the far-reaching part of this
Fabric.
software. So I just wanted to listen a bit to others speak, then I will contribute mine also.
I see. Is today your first time or you've been
Yes,
joining for
yes,
the past
yes.
weeks?
No, it
Okay,
was my
today.
first time. I wish I had known about this earlier. Yes.
Oh, I see. That's fine. Okay, thank you so much, madam.
Thanks.
Mr. Victor, please unmute and speak. I know you've been joining us for a while. Hello, Mr. Victor Bassi. You might not answer the question, but just, excuse me, tell us your experience with Microsoft Fabric. Okay, can anyone else tell us his or her experience on Microsoft Fabric? Today will be our
Hello,
virtual.
Hannah. Good evening. Good afternoon.
Yes, good
Hello.
afternoon. We'll be trying to reach you. We can hear you now.
I'm so sorry, please. I was on something. In fact, in all honesty, Niger Data Form has been so very awesome with the Microsoft Fabric thing. It's really been, as in, when I mean really, really, really awesome. It's just you guys, as in Mr. Rashid and the team, Yuhani, and every facilitator has been very, the delivery has been very awesome. But one other thing really I will love if possible. I mean,
Yeah,
when I mean if possible, is
yeah,
how do I call it now? For example, while Mr. Jami was even just, I just had to quickly go to his LinkedIn because I noticed his delivery and I intend to want to connect with him maybe on something much more personally, or something
yeah,
much more, maybe as a kind of advisory on
yeah,
how to really, because even I heard him when he was even saying, oh, even as a beginner, there's a repo, so very awesome. Sometimes because I've also engaged in similar thing and everybody just assume everyone understands the flow and all of that. But at least with him, it's going to be a very good one. So my little suggestion to Hani, even like I once told Mr. Rashid too, is to some of the videos or to some of, if possible, maybe should I assume maybe before even the commencement, if it's possible, we can just have like a kind of a train of the curriculum. When I mean train of the curriculum or whatever, as you intend going about it, so that okay, for example, as this one has ended now, there
yeah.
could be, because then what Mr. Jami was even saying, it was on Google Colab and all of that. I was like, so this fabric can do all this even outside the collab or pattern notebook and all of that. So I would have appreciated, maybe, I don't know, maybe like you said, I intend to go into that GitHub repo to see maybe how those other things are broken down for my own personal development, to have a deeper and better knowledge of, you understand. So it's awesome. It's a great work. It's a great. I know it might not be easy. It might not be challenging, because it's not just coming into, just like the last speaker said, you're not just coming to hear it, but the having it in depthly, and you can be able to practice it, you can replicate it, or it's the ultimate. It's the ultimate behind all this, and I'm so grateful. Thank you so much. Mr. Jami, my kudos to you. Thank you so much, sir. I'm very, very grateful. Thank you.
Thank you, Mr. Victor. That's a good feedback. But were you able to maybe leverage on the link Mr. Bayo shared
Honestly,
on?
I've not been working on some projects. Been working on, even that last week when I joined, I had two laptops open, and one, there was a target needed to wrap up on something. So I've not really. I just intend to want to use this weekend, complete what I've been on, then I'll revisit
Uh,
and come back. Like the way I do disturb Mr. Rashid, sometimes at the end of every prayer, I'm like, please let's have the video. But in a while, I've really not been. Honestly, I've really not been. But I intend to. Even please help tell Mr. Ahmed Olanrewaju to that our video he said he was going to. We are still waiting for you to. Yeah, has not make it up.
Oh, okay.
Mr. Ahmed
Is it
Olariwaju.
the recording of the class?
You say?
Or did he say he was going to give a separate
No. You
recording?
know that no. That video at the starting then, it was having series of network. So he said he was going to do a video of everything
Oh,
and post
okay,
that,
okay. I'll
which he
remind
has not been able. Okay, please.
I'll
Thank you
remind
so
him.
much.
He's currently outside the country. I'll
I know.
remind him.
I saw his post in one thing in Kenya.
Yeah, yeah. He's in
Even it,
Kenya at the moment.
I noticed that. So
Mm.
because the thing about it is that thing he started with will have been a very good leverage to as in proceeding into so many of all these things going further. And it was setting a very good foundation, but unfortunately, network wouldn't allow him.
That's
All right.
Nigeria for you. Thank you so much.
All right. Thank you so
Yeah,
much.
Mr. Bayo, do you have a further question to ask your audience?
Mr. Bayo, please, I'll connect with you. I've already connected you. My name is Victor Bansi on LinkedIn. Thank you so much, sir. I really
His
appreciate
name is actually Bayo dot py on LinkedIn, so it's not
I've seen
Jamie
it.
on LinkedIn.
I've seen it already. I've seen it
So
already
if you
on
go and
LinkedIn.
look for Jamie, you might not see him. Oh.
I know, no. I know it's Bayo.
Okay, Mr. Ola, your hand is up. Your hand is
Yeah.
raised.
Okay. Good afternoon, ma. What I just want to support what Mr. Basi said that the video is very important, especially with we are just coming into the data science and field. So we need that video. That it
Mr.
will lead
Bayo,
us.
you don't have disciples, so you can see all your disciples in data science.
So that's what I
Oh,
just want to contribute. All right.
Okay,
All right.
thank you, Mr. Ola. Thank you so much. Who else has something to say? We are rounding up. Okay, Mr. Bayo, you have advice for your people? Word of guidance,
uh,
words of wisdom?
all right. Okay. Can you see me, ma'am?
Yes, I can. You are audible, loud and clear.
Okay. I'm trying to preview the last to say. Okay. Oh, so I'm typing the so if I wait, so yeah. So that's the name on LinkedIn. But on Twitter, I think it's via the QR. Yeah. So on the group on the WhatsApp group, yeah. So once you just send me a text on the WhatsApp group. So my number is this 338274701. So once you just text me on WhatsApp, I will try my best to respond. So generally it's actually been a nice experience with everyone on the community. And then one thing is that to start with, the community is trying to build something that is not always very common. And then it's always like everybody starts from somewhere and then they end up somewhere. So among the tech community, I only see that data is still like the one of the least technical, and then because there is a lot of development going on to support between data that every other guys are not really enjoying as we are enjoying. So now let's say you're interested in becoming a data science and you have a platform like this that brings those kind of consciousness. So one thing that I can guarantee is this: if you manage to get the recordings, yeah, I didn't assume that people that we are going to train know or have some sort of background in the whole space. So the thing is not like how do you make sure you get to the end where you can even like be working as a data scientist that is going to be building commercial ML algorithms or models because you if you don't use it in workspace, if you don't give it out for people to use, if you don't commercialize it, it means that you're just building projects to satisfy your to just satisfy yourself. So what happens there is that where do you start? You can start from somewhere like okay, you even need to get familiar with statistics. That part, a lot of people always try to like skip it, but it's not really very good. I didn't have a background in statistics. I didn't even have my degree in statistics. But as I'm trying to master Excel, I'm trying to understand, okay, what are they doing with mean? What is their goal? What are they trying to achieve if they say average of something? What are they trying to do? So by the time I watch a lot some videos around those things, I already grab those concepts. If I try to visualize data in some sort of, let's say, line chart or bar chart, I go ahead and say, okay, is this the right chart for it, statistically speaking? Then with that, within like a couple of months as I'm working on several projects, I will see that I'm having some sort of understanding of statistics as we go on. Then after you understand statistics and basic math, then you can just dive into, okay, the language they use to even do bring statistics to life, implement it, that we've been writing so far. We are just talking about concepts, but we are seeing code. We are writing the code there in notebook. The language is basically Python. That's why I said to start, go start, then go to Python. So if you go to Python, where do you learn Python? There are lots of information online. I think the most consolidated one so far that I've seen is still that from Harvard school. So they train their students, but they make it available for us free of charge. I think the students pay around $4,000 per year to even enroll on that course. So if you have that kind of course that open up Python how to use it. So by the time you finish that course, you will be able, I'm very confident, because the guy was very, very simple in his teaching. So you will be able to use Python to develop not only for data, to even build some interface. It's because I know how to use Python to build some small interface. That's why I was able to build that Streamlit. So I can build a lot of small projects around Python and everything. Then I'm okay with Start and Python. So now, how does that even now comes together to help me as a data scientist? It's not like I will now go and say, okay, out of Python, I have what they call pandas and NumPy and other libraries. Then I now begin
I'm
to use
requesting
them.
for
So,
link
so I
to
now,
Python course.
okay.
Yep.
Oh, okay. So the link is on the GitHub page. So let me kind of like get the GitHub page this thing. So if you come to GitHub, I think the code is the link to the GitHub has been provided. So that is why I made sure that so that the class won't just be we just come to class and everything. So if you come right here, if you want to learn Python programming, this is just the link right here. Then now in Python, there's a pandas module. To learn the pandas, to be able to manipulate data with pandas, regardless of the size, you can learn pandas here. Then to visualize some sort of data, let's say you want to build some graph and charts, you can learn Matplotlib. The links are right here. And they are not linked that you just go and learn a lot of things. They are very, very organized. That's why I went to research them and bring them here to keep everybody on the same listing. Then now we now go to if you now want to learn, you learned Python, you learn statistics, you've already mastered pandas. Then the next thing is that start building your project. If you don't build those projects, all those things will fade away. So now, how do you build projects? If you want to do machine learning, just think about a project that you can fix, a problem that you can solve, get the data, then now try to say, where do I want to build it? Fabric is the best place to start. So just go to Fabric, sign in for free trial, 60 days. Then you know that just screenshot this environment that you are seeing here and say the process that I just need to do is that bring my data to Fabric. And where do I bring it? Inside the lakehouse. Then after I bring it inside the lakehouse, I just need to open a notebook, then start a notebook. What do you do after that? I start to explore those data. This is where you will now use Python and pandas that you have learned. You will use them extensively here to do this operation. And now you can now fall back to Data Wrangler if some things are not clear to you. The code will be generated because you now know Python and pandas. If you see the code that is generated by the Wrangler, you will be able to read it and understand as normal English. Then we now move on to data pre-processing. Okay, my data I've already cleaned it, everything is okay, but some numbers are there, some letters are there. I want to bring everything there. And I know that I need to split my data into two things, train it, test it. How do I do training? How do I do testing? All of those things, you can see them on this guy's page, all the concepts. And he's not explaining it as a mathematician. The guy was explaining it, the professor was explaining it as a newbie to everyone. So by the time you bring two projects, you now go back and test yourself and try to imagine what the values that you can contribute to the workforce. Then you will see that it's going to be tremendously huge. So it's because I know Python, I was able to switch between engineering and scientist and AI at the same time. So Python is one of the most lucrative skills that you should have. Then just be thinking holistically. If you can't, everybody can be a builder. If you can understand so many concepts, you can work in governance, you can guide, you can team lead. So that's still one of the approaches. So just keep mind open, put in the work. It's going to be very stressful to learn. It's always not very easy, especially when you curve like let's say 25. Learning is always very, very difficult for people above that age. So we should always just be ready to say, okay, we won't give up, and then always ask for support on the group page. Text us, text everybody, ask for help. We are here to help every time. Yeah.
Mr. Victor, your hand is raised.
Hello, thank you so much, Mr. Bayo. Thank you so much. In fact, I was just looking at the gator you were displaying. Really awesome. Please, I'd like to ask, I've heard this thing. Why is it always in course of testing and training? Oftentimes they do 80 and 20. One. And secondly, regards that link you sent for the to learn that first link you were sending that is 4,000. Does it mean one have to pay $4,000, if I may ask, please? Thank you so much.
Oh, sorry, please. Can you come again, sir?
Okay. Hello, sir. Am I audible?
Yes, you're
Can you hear me,
audible.
sir?
It's audible. I can hear you
I
now.
actually wanted to. I actually wanted because last week I remember when you were walking, though I drifted in between and today. Why is it always in course of testing and training they do 80-20? Why that? Secondly, then in course of this link, when you were saying, oh, their student pay 4,000, that link to learn, they pay 4,000 USD. Has it been made open, as in for people to access now freely, or one still have to pay 4,000 to access it? Access it, please. Thank you.
All right, sir. So can you hear me clearly now?
Yes, I can. I can.
All right. So the major reason why people try to split train data sets in this thing 80 to 20, 70 to 30 is let's try to reason what we're trying to do. What we're trying to do is that we're trying to make predictions about something. So
Okay.
it's not like we have two operations going on, training and testing. So we found out that if we use 50-50, we are going to have less data. It's always very complicated for, let's say, for us to draw conclusion from analysis in this kind of area. Then we need as much as information needed. That's why we don't train machine learning with 10,000 lines of rows of data or 15,000 rows of data. We actually train with more than millions so that we will be able to get as many as possible scenarios that has happened. And if we now have
Sir,
1
did you say
million
we
rows,
train actually with more than millions? Is that what you said?
yes, yes, we've
Wow.
always most of the commercial. Let me give you a very profound evidence. When we are trying to build something like this system for a financial institution, the significance of our work, like the impact of our work is this. The bank makes a lot of money from loan, interest, and all those things. And I'm trying to tell them that, you know what, every analyst that analyze people that check if people will pay back and check those things, dump them. Try to use my model. My model will tell you that this person will pay back. And there are going to be a lot of investments going there, buying you license to work, getting some sort of data for you, because as you are storing data somewhere, you are paying for it. So all
Mm,
those kind of things that they've invested, they expect some return. That is, their loan default rate should come down. And if it doesn't come
mm,
down, that means you actually led the whole team wrong. That's the significant impact of your work. You are changing the
mm,
operation globally. The banks work in like almost 8 countries. You are going to be
mm,
deploying a lot of models outside, and you are going to say, okay, they are going to lose a lot of money. We are talking about billions. So to be able to catch all those things, we need as many as possible data that we have. Sometimes we even work with Microsoft guys, people at Microsoft to call them the scientists to work together with us and all everything. So we have a lot of data sets, sometimes more than we have 20 million AML powered, 20 million rows powering an ML. So once we have that, we have already provided a lot of data. You can't compare it with this model that we just built now that is 32,000 rows. They are now like, if we now have 20 million rows, do we want our model to now even just take 30 out of it? That's a waste. We need to let it learn more. Then we now be like, okay, let's even take 80% out of it. If we take 80% out of it and it predicts 20%, that is around I don't know even know the figure. So now let's now say we take 20% out of it and we use it to predict. Then it's not going to be like if it gets a significant performance, a useful performance prediction out of those 20%, then we can now still go and bring a new set of data entirely. So it's not always that we always train with and conclude that our model is doing well. After you train it 20%, still go and bring.
Hello, Mr. Jamiu.
Then we lost
Wow.
him. Awesome
Yeah,
delivery.
that's network. Um,
But honey, I may I ask, are you going to make available that GitHub, that repo?
yes, yes. I think I've made it available from the after the first
Okay, from
class.
the onset. Okay.
Yes, after the first
Yeah,
class he had.
I'll go over them very well. I'll
Mm,
look into them. Thank you so
I
much.
can
Yeah.
repost it anyway. I can repost
All right.
it. Mr. Ola, your hand is still raised. I don't know if you still have question. Mm, okay, so at this point,
Oh, sorry, my network
yeah,
just signed me off.
yeah, we lost you for a couple of minutes.
Okay. So now, to wrap up that particular one, it's not like to check for 70/30 last one. Another thing I will now do is that we review the algorithm that we are trying to do. So is the algorithm heavily depending on model or is not depending on model like that? Because some algorithms are called lazy algorithm. They don't build a model. They actually just compare some extreme cases to be able to predict the value of something. So those ones are not heavily depending on algorithm. Some of them that depend on algorithm, we really make sure they see a lot of data, a lot of data. It's just that let's say we want to do object classification. Before we will go and get as many as possible pictures that we can see. But these days now, with help of neural network, we don't need to do that again. We just go very detailed. We overanalyze one picture, and then we get a lot of things. So you just check your algorithm, check the impact of what you are trying to build, then you trade off from 60, maybe 70/30, um, 80/20. You can even try it yourself. Do 60/40 or 50/50 and see your performance. You will see that you will see some sort of decrease in the performance. And then the students that are paying 4,000 students, yeah, they are basically people that are even enrolling in the school that I'm talking about. So if you take a Stanford course now on machine learning, those students that are in the class where they are recording it actually paid some sort of money, 4,500, 4,000 to even enroll on the course. So they just feel like they should make it open and accessible to us. They just view it and record it and put it on YouTube. And they feel like, oh, we deserve it. We shouldn't just waste this opportunity. We just need to use it to our own advantage. They are trying to help. We just make the effort count. So that's what I was just trying to say there.
Okay, so invariably you're saying we can access it. That's what it means. It's accessible freely. Is that?
Yeah, sure. This particular link that you are saying, this CS50 or let's say Stanford own, they paid for it.
Yeah,
They
that's
just put it
Stanford.
online for us to use. Yeah,
Okay.
sure. So if you go to Harvard
Right.
today and you enroll in computer science, you know you pay for your semester, right? So you are paying for your semester, you are practically paying for the course, but it's just online for you to consume.
Right. Thank you so much.
Yep.
Right. Thank you, everyone. Thank you, Mr. Bayo. Any further question? Questions, comments? Okay, I think is it?
Hello, hello, hello,
I'm talking.
hello,
Hello. Yeah.
hello, everybody. Hi.
Yeah,
Good evening.
good evening, Mr. Tosin. Good afternoon.
Um, I came late, so I don't know if it has been done. I believe today. Hello, can you hear me?
You're breaking up.
Oh God. I believe that today is Mr. Rashid's Dean celebration. I came in late, so I don't know if this forum has had the opportunity of wishing him well.
Well, actually, we have been on this platform before he posting the frame on the chat. So, and I think people have
Oh,
begun
okay.
to wish him well. Yeah, yeah, yeah. So the meeting
Oh,
has
okay.
already
I came in
concluded,
late.
and I didn't want to break the flow of the
Oh, all
meeting.
right.
So we can go to the chat and wish him the best of luck. You can give him a call. You can love him as much as you will. Thank you, Mr.
All right.
Tosin.
Thank you. Thank you.
Yeah, yeah. All right. So thank you everyone for joining. We appreciate your time. We appreciate your call. If you are not here, we wouldn't be here. If we prepare and you are not here, we can't teach ourselves. So we really, really appreciate you. Mr. Bayo, we appreciate you so, so very much for 3 weeks of selfless, time and sacrifice to be with us, to train us. We really appreciate, and we pray that the Almighty God will bless you immensely and increase you in wisdom. Thank you so very much. Thank you, everyone. So,
Amen to Mr. Bayo. Amen. I'm
so
saying amen to that prayer for him. Oh.
yes, yes, yes. God bless you richly. So we'll be communicating on our group chat. And if you have not joined our Microsoft Fabric community, please do us a favor. Try and sign up. I know Mr. Rashid has been posting um, the link on our group chat. Please join so that we all can grow the community. So further information will be communicated to us via the group chat as well as on our community platform on Microsoft Fabric. So thank you very much. God bless you all. Have a blessed weekend and a great week ahead next week, and a fruitful week ahead next week. Thank you very much. God bless you all.
Thank you very
Thank you.
Bye.
much.
Thank you. Bye.
Bye.
Thank you. Bye, Ma.
Bye. Bye,
Bye.
everyone.
Thank you very much, ma. Regards to everyone. We love you all.
Yeah,
Bless
I
you
love you
for the
all.
effective
Bye.
delivery.